Mathematical models are designed to answer many questions. They can be used to predict the weather, to analyze ups and downs of an economy, and even to develop speech recognition. Information can constantly be analyzed and gathered and stored. But can that information give the answer to a moral question? A mathematical model may be able to show us a fairly accurate depiction of the rise and fall of the stock market and might even be able to predict future trends. But that model can't tell you whether or not investing your money in stocks is a wise decision for you. We have to use discernment to make good choices. Math can give us important data to consider, but it can't make the decision for us. It can't tell us what is right or wrong. A model may be a good way to lay out a moral problem and understand it better, but only God can provide the additional information necessary for answering moral questions.
Welcome to our new chapter. Our question for today in this section is, how is the order of operations used in solving equations? We're going to have a little bit of an unusual answer to that. You'll see as we go through it. So what are we going to cover today? Identifying the properties of equality and applying them to solve equations and real-world problems. So what I'm going to have you do is warming up by, I'll give you an equation and a number to plug into the variable, and you see if that comes up with a true or false statement. Okay, let's check the answer. Now, number 1 is true. Why? Well, when you put 2 in, you get 7 times 2, 14. 14 minus 9 equals 5? Yes. Look at number 2. You put negative 1 in. Is 4 minus negative 1 equal to 3? No, 4 minus positive 1 equals 3. So number 2 is a false statement. So what we're doing is we're taking an equation, we're putting the variable in, and seeing if that gives us a true or false statement. And that leads us into the solving equations. Actually, it's kind of a little bit more of the check, but it's part of that aspect of it. What is an equation? Well, before we get into that, what's it good for? Algebraic equations are useful in describing the world that God made. And there are many, 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 many things in science and applications of math and economics everywhere that use equations. So what is it? An equation is a mathematical sentence stating that two expressions are equal. Now, why did I bother circling those? Because is and are linking verbs. They link together what? The subject and the predicate. No, this isn't English, okay? But there is an is in a math equation. What is that is? The equal sign. So before we had expressions, now we're getting to equations. There's going to be an equal sign. A number that makes the equation true, like we practiced just a few minutes ago, that's the solution to the equation, the answer. So when we put in, I forget the number, we put in 5 and in for A in number 1, that was the solution to that equation. That was the answer. What is the right number? So that's what we're going to be doing. Here's the equation. What's the answer? What number makes it a true statement? An inverse operation is a math operation that reverses another operation. And we've already talked about that right here. Remember last chapter? These are inverses of each other. So here's the basic point. What we're going to be doing is you look at the equation, and whatever is done to that variable, we have to do the inverse. We have to undo it to get the variable by itself, to get x equals, and that's the solution. So when you have 7x plus 14 equals 90 or something like that, What is x? I don't know. We have to undo that stuff so that we get x equals, like you did in the warm-up, that's the solution. It's that simple. So how do we do that? Well, we undo by using these properties. The addition property, what does that say? It says if A equals B. In other words, if I have an equation, here's my equation. You know, what did I say? 5x plus 7 equals 90 or something like that. Okay? That's my equation. Okay? I can add equally, you must add equally to both sides. And that is an acceptable thing to do. Mathematically, you'll not change the equation. Now, can you add to one side and not the other? Or can you add unequal? No. If you add 5, you must add 5. If you add -5, you must add -5 to both sides. Okay, so if you have x minus 17, what is this? That means you are subtracting 17. Now remember, what's our goal? Get the x by itself. X equals, that's the answer. But 17 is subtracted. How do you get rid of subtraction? By adding. So you add 17 to both sides. Can you see how that's what we had up there? Now, what is -17 plus 17? Those are additive inverses. We had that before. They add up to 0. It's gone. Poof. And what do you have on the left side? X, and of course, -35 plus 17, -18. That's the answer. That's the solution. It's that simple. So whatever's being done in the equation, we undo it with the inverse to get the x by itself. Oh, x was subtracted by 17. Add 17 to both sides. Well, there's a subtraction property, same thing. If it is added to both sides in the equation, you undo that by subtracting on both sides, and there's the answer. Okay, that's it. You're undoing what is done in the equation as it's written to get the x by itself. Now, that's for addition and subtraction. So whatever is done, you do the other. If this is done, you undo. If this is done, you undo. Is that going to be the same thing with multiplication and division? Absolutely, definitely. If you have the equation, you can multiply to both sides. So here we have a division in the equation. How do I get rid of division? Do the inverse. Multiply by both sides. Can you see how the 5/5 on the left is gone and you're just going to have an x and 105 on the right? So if there's division in the equation, undo it with multiplication. Well, what if there's multiplication? Then you undo it with division. Now, notice that little requirement there. Can you divide by 0? No. Well, there wouldn't be multiplication by 0. Because if you have a times 0 equals b times 0, you have 0 equals 0, you don't have any equation. But the point is never divide by 0. Okay? So in this case, we have a multiplication by 3, so we're going to divide both sides by 3, and boom, there's our answer. So always, 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 always do equally to both sides whatever operation undoes the operation that is in the original equation. One more thing, the symmetric property. What does it say? If A equals B, then B equals A. So what's on the left side can be on the right side and vice versa. Okay? Symmetry. In biology, we are laterally symmetric, at least externally, not internally. The heart's on one side and all that. But if you have the normal body and you're not missing some limb through an accident or whatever, then what's on one side is the same as on the other side. You know, leg and arm, eye, half a nose. That's symmetry. It's balance side to side. Equations. If you have 5x equals something, you can swap sides. It doesn't change the equation. That kind of makes sense, doesn't it? So if we want to get the x, and usually we want to get the x on the left side, then all we have to do is just swap sides. Now notice we're not changing anything. There was x plus 10, there was a 4. You keep everything the same, you just exchange the sides. So what that means is if the variable is on the right, you can rewrite it on the left, or vice versa. One more definition, we'll get to problems. Equivalent equations are equations that result in the same solution. Now, if you remember, we had that x minus 17, that was back here, equals negative 35, and then the x equals negative 18. Okay, so both of those are equivalent equations. In that original one, you can put negative 18 in and get a true statement. In the answer, x equals negative 18, you put in negative 18, you get negative 18 equals negative 18, true statements. So those are equivalent equations. They have the same answer, they're just in different form. Okay, let's get to doing it, solving it. What's happening? X is being subtracted by 12. So what do? I undo by the opposite, by adding 12 to both sides. There's my answer. Now you should check. You put the 27 back in the original equation. Is 27 minus 12 equal to 15? Yep. Second, there's 2/3 added to x. So what I want to do is the opposite. I want to subtract 2/3 from both sides. Notice that there on the right, in order to subtract, remember this from elementary school, if you're going to add and subtract fractions, they have to have the same denominator. So we rewrote the negative 2/3 by multiplying by 4/4 as negative 8/12. Now we're ready to do the addition subtraction and get x, and then that's going to be negative 15/12, which reduces down to negative 5/4. Do the check. Is negative 5/4 plus 2/3 equal to negative 7/12? So here's what's up here, and there's our answer. We're seeing, is it equal to? Okay, well, the negative 5/4, that's negative 15/12. The 2/3, that's 8/12. Is negative 15 plus 8 negative 7? Yes. So that is a solution. It makes the equation true. And those are equivalent equations. Letter C in number 1. We have negative 8 equals x divided by 7. Okay, let's get rid of that division by multiplying both sides by 7. Of course, 7/7 on the right, it's 1, reduces to 1. So you get negative 56 equals x, and then we're going to use the symmetric property to exchange the sides and put our x on the left. Is it wrong to say negative 56 equals x? No, it's just not the standard way of doing it. So flip it around and say x equals negative 56. It's time for you to do a few. Okay, let's check the answers. What is the property? Well, you want to subtract 7 specifically. That's the operation. That's the subtraction property. You want to divide both sides by 4. That's the division property of equality. Now, since the solution can be checked mentally, in other words, you have, something plus this minus that, then you don't have to show the check on these simple problems unless you're told to. That's the basic statement there. So what are our steps to solve equations? We determine what is the operation that was performed on a variable in the equation. What does that mean? Oh, x minus 12. Oh, it was subtracted by 12. Okay. Number 2, perform the inverse operation on both sides of the equation. Oh, x minus 12. Oh, you add 12 to both sides. Okay. Simplify both sides of the equation. Check your answer. Find out what is happening to the variable, do the inverse operation on both sides. So we're undoing. Now remember, what we did in chapter 1 was all numerical. And so we went through and we did, and we followed an order of operation. Now we're doing equations that have things already done that we have to undo to get to that answer. So this is very important. Solving is undoing. How many times have I said that in this lesson? So the order of operations must be used in the reverse order when you are solving equations. The order of operation order is when you have numerical expressions. But when you're solving, you're going to do it in the reverse order with the last two steps. Okay, now with equations, if you have PEMDAS, or we have GEMDAS, the grouping symbols and exponents, those have to be done, period. Always. But then we get to where there's just a bunch of multiplication, division, addition, subtraction. When you get down to that, those last two steps, the MDAS, they are reversed. You are undoing, so you do it in the opposite order. Now, if you've had our courses before in the BJU Press, in fundamentals and pre-algebra, I've given you the same illustration I'm going to do. In the morning, you are putting on your shoes and socks. What goes on first? Well, it better be the socks, right? And then you put your shoes on. Then you go to school, you go to church, you go wherever you're going, if you don't go to school, but you know what I mean. So you come home. What do? Do you take off your socks first? Well, duh, no. I take my shoes off first. Why? You're undoing what you did in the morning. So the last thing you do has to be the first thing you undo. You know, you're building something and you put this all together, the last thing you do is tighten the bolt. What's going to be the first thing you do to take it apart? Loosen the nut off the bolt. Okay? So we flip the order of operation. The addition, subtraction is undone before the multiplication, division. Undo the addition or subtraction, then undo the multiplication or division when you're solving an equation. Like it says ax plus b equals c. So that means the x is multiplied or divided, and there's also addition or subtraction, and then it's equal to something. Doesn't have to be ax, but 2x plus 5 equals 7. It could be negative 14x or x divided by negative 14 minus, but if there's a multiplication division, there's an addition subtraction. Flip the order because you're undoing. Okay, so to solve this, the first thing we have to do is undo what? The addition or subtraction. So we undo the addition by subtracting from both sides. Now we undo the multiplication by 2 by dividing both sides equally by 2. There's the answer, and then you put that in for a check. 15 plus 6 equals 21? Yes. So undo is solving equations, and undoing uses MDAS in the opposite order. So what is AS? MD. Add, subtract, multiply, divide. Asymptom. Whatever that sounds like. Here's letter B. First thing we do is get rid of the minus 3.6. And then we get rid of the division by 1.5 by multiplying both sides by 1.5. And now, we're in chapter 2. Pull out your calculator if you want. It's fine with me. I asked you to practice doing the 1.5, 0.8, negative 1.2. Okay? And you check that and put that in. And yes, that does come up with negative 4.4. It's time for you to do some. All right, let's check the answer. You subtract 9. You divide by negative 4. and come up with -8 for the answer. And you could check that and verify that -8 times -4 is 32. 32 plus 9 is 41. I won't do the check on the other one. Okay, we subtract 4 from both sides. We have y divided by 6 equal 5, so we have to, multiply both sides by 6. That gives you y is equal to 30. And that also checks. Okay, so we learned some very important stuff. Make sure you have it. Now, next lesson is going to continue this section. Okay? But this is a must get a hold of. You must understand how to solve these equations. And we'll be back to continue that on.